common related rates question is the volume of a cone. Let's take a look at an example. A conical tank with vertex down is 10 feet across the top and 12 feet deep. As soon as I read that first sentence, I think, let's draw a picture. So here's my conical tank with vertex down. Circular base, vertex down. It says the cone is 10 feet across the top. Now that's the diameter, but what we use in the problem is the radius. That's why I'm going to cut that 10 and a half and label the radius as 5 feet. And it says the cone is 12 feet deep. What we've created here is a right triangle that we're going to use in just a little bit. Water is flowing into the tank at a rate of 5 cubic feet per minute. Looking at the units there, 5 cubic feet per minute, we can see that that's the rate that volume is changing. So that would be dV dt. Because water is flowing into the tank, that rate for volume is positive. If water was flowing out of the tank, we would want to make sure to make that rate negative. The problem reads, find the rate of change of the height of the water when the water is at a height of 4 feet. So we are looking for dH dt when the height of the water is 4 feet. As I mentioned before, the formula you're going to use here is the volume of a cone. That formula is V equals 1/3 pi r squared h. Now before I differentiate this, let's take a look closer. Is it okay to differentiate volume? And I would say yes, because we have the dV dt here. Is it okay to keep r and h in our problem and differentiate those? Let's think about that. If we were to take the derivative of this right side, we would have to incorporate the product rule. When we use the product rule, that would give us a dr dt in there somewhere and a dH dt. Now the dH dt in the problem is okay because that's what I'm looking for. But this is the problem right here. We don't have a dr dt, nor do we have a way to find that. So that's what we want to get rid of. The way we get rid of that is by replacing r with something else that we can substitute in so that we don't have a dr dt when we differentiate. The way to do that is to go back here and look at these dimensions of our cone. Now, what's true of any cone is that no matter the height of where the water is, let's say it's right here, the ratio of the radius divided by the height will be proportional no matter where the height of the water is. And the reason for that is because you have two similar triangles here in your cone. So once again, the ratio of the radius divided by the height in this cone will always be 5/12. By solving for r, simply by multiplying both sides by h, you can see that the radius will be 5/12 times the height. That's what we are going to replace r with over here. So let's go ahead and do that. Our volume is equal to 1/3 pi, and then instead of the radius, we're going to replace it or substitute in 5/12 h squared and then times h. With a little simplifying, we have derived our volume formula, which is 1/3 pi times 25 over 144. H squared times h would give us h cubed. And you know what? Let's multiply the 1/3 times the 25 over 144 to get 25 over 432 pi h cubed. What we've just done is we've derived the volume formula that we're now going to differentiate. Speaking of derive, it reminds me of subscribe. So if you're finding this video useful, please subscribe. I would be so grateful. So now it's time to differentiate this. The derivative of the left side is dV dt. The derivative on the right side, well, we have the constant 25 over 432 pi out in front. The derivative of h cubed would be 3h squared times dH dt. Let's plug in what we know. We know dV over dt is 5, and we know that h is 4 feet. So let's plug in those values. Now, if we clean the right side up a bit and multiply those numbers together, we would get 25/9 pi dH dt. And then if we divide both sides by 25/9 and also divide it by pi, we arrive at our final answer of dH dt equals 9/5 pi, and that would be in units of feet per minute. Please help me get a positive derivative to this subscribers versus time graph by subscribing. Thank you so much.